Hi everyone, in this session I would like to explain a few problems on time dependent probability evaluation, numerical problems. Here this is the first problem, that is a component with an MTTF, mean time to failure of 100 hours is known to have exponential distribution. So now this is time dependent probability evaluation using exponential distribution. Then what they are asking, calculate the reliability of a component for a mission time of 10 hours. Reliability of the component R of t we need to calculate. So if you see the solution now, first we will take the data given. What they are given, MTTF. What is that? 100 hours. You know that this MTTF is also equal to lambda. So from this, that is 1 by lambda is equal to 100. From this you can calculate what is the lambda value. Lambda value is 10 power minus 2. And they are given mission time of 10 hours. So then time t is equal to 10 hours. Then what they are asking finally, calculate the reliability of the component. It is R of t they are asking. So very simple problem. R of t they are asking. You know that R of t using exponential distribution is equal to e power minus lambda t. You know all the values, just simple substitution only. E power minus lambda is equal to 10 power minus 2 into t, that is 10 hours. That is e power minus 0.1, that is equal to e power minus 0.1 is equal to 0.9048. This is the reliability of the system. Reliability of the each component in the system, right? Now this is the second problem, that is consider a system consisting of 6 identical units of each having failure rate lambda they have given. Failure rate of 0.2 failures per year. This is the unit for failure rate lambda. Then they are asking in two questions, that is first one is find probability of success of the system probability they are asking, the two with respect to success. If it is, see they are given the condition, if it is fully redundant configuration, that means all components are working satisfactorily, fully redundant configuration for a time period of 1000 hours. Second one they are asking, find the probability of system serving at least 4 out of 6. The previous one, that is fully redundant, means all are working satisfactorily. Here they are giving a partial redundant system in second problem, that is 4 out of 6 units must success for period of 1000 hours. Then assume exponential distribution you have to follow with constant hazard rate function for the probability of components. So now we will see the solution for this. First collect the data they have given. What they have given, lambda value they have given it 0.2 failures per year they have given. This unit is very important, failure per year they have given. And From this we can calculate mean time to failure, that is 1 by lambda, that is 1 by 0.2, that is equal to 5 years. That is mean time to failure. So now first problem is they have given the fully redundant configuration, that means all 6 are working satisfactorily. Then we need to calculate system reliability RS of t, where this S represents the system. RS of t, that is equal to 1 minus QS of t. Okay, so that is fully redundant configuration means which system is it? That is parallel system. All 6 units are in parallel like this. That is a parallel system. All 6 units are in parallel. So if they are in parallel, it's better to consider, if it is better to go with the QS of t. That is just a simple rule of product rule we can follow. So that is equal to 1 minus, that is Q1 of t whole power 6. Because if you consider this is for component 1 to 6, Q1 of t, Q2 of t, Q3 of t, Q4 of t, Q5 of t, Q6 of t. So all are identical, they are given. Identical components, all are equal to Q of t. That means Q of t is equal to Q1 of t is equal to Q2 of t is equal to Q3 of t is equal to Q4 of t is equal to Q5 of t is equal to Q6 of t. That's why here I have written like this. That is Q1 or Q of t whole power 6. So now we can simplify this. 1 minus of this is Q, we can write in terms of R. This 1 minus R of t. That is 1 minus of R of t whole power 6. That is equal to 1 minus of e power minus lambda t whole power 6. Okay, are you getting my point or not? So now from this we can write like this: 1 minus e power minus lambda, they have given 0.2, t they have given 1000 hours, they have given c, they have given time in hours, they have given this what do you call this failure rate in failures per year. So here by year is there, here hours are there. So then we need to convert these hours into 8760, that is into year. Just you are converting number of hours into years, number of years, right? So then that is for year you have 8760 hours. So then 1000 hours by 8760, because here this is in years, that way we are converting. So then both we are bringing to a single or common unit. So now after simplifying this will be equal to 0.9995781. 0.9995781. This is RS of t. That is for the first problem. Second problem, what they have given? See, second problem they have given out of 6, 4 for at least 4 least 4 out of 6 units. That means maybe 4, 5 or 6, up to 6. Any number of units can be satisfactorily worked, right? So then in this case Rs of t is equal to, we will start from 4, 6C4, yes or no? R of t 4 Q of t square plus 6C5 R of t 5 Q of t whole power 1 plus 6C6 R of t whole power 6. Then there is no q of t, actually q of t whole power 0. Okay, now 6C4, that is 50 e power minus 4 lambda t, okay, into q square, that is 1 minus e power minus lambda t whole square plus this one now we are writing 6C5, that is 6 R of t whole power 5, that is e power minus 5 lambda t into 1 minus e power minus lambda t. Now this last term we are writing plus, okay, what is that, e power, that is R of t 6. So now 66, that is equal to 1 e power minus 6 lambda t. So after substituting where lambda is equal to 0.2, t is equal to 1000 by 8760, finally we will get the answer 0.9. You can calculate later. Okay. This is a problem on time dependent probability evaluation. Okay. Hope this is clear to you. Thank you.